The reason that automation is an important topic for us is because machines have made a huge difference to the world. Automation is a really important idea when studying interaction because the ability of machines, whether they be mechanical machines or computational machines, to do things autonomously or automatically changes what humans also need to do. Designing autonomous machines involves designing behaviours, both the machine behaviours and indirectly the behaviours of users who interact with them. Technological automation by humans has a long history, stretching back to the earliest tools like stone axes and the use of water wheels for milling grain. It became especially significant in the Industrial Revolution in the late 1700s, with the development of the steam engine. These engines were used for many tasks, including transport. As with many technologies, steam engines were initially framed by the processes they replaced. For example, early steam trains replaced horse-drawn carriages, and the design of early steam trains looked a lot like horseless carriages connected to run on rails. Over time, they took on their own distinctive form and technological character, only to be replaced by ever newer motorised technologies including combustion engines and electric motors. The steam train drove massive change in the transport industry as we know it, including steam-powered trains, tractors and ships. These transport vehicles were one of the most visible changes of the steam engine revolution. It replaced all sorts of other mechanisms that we had before then. Steam power replaced horses and buggies, it replaced bullocks pulling ploughs, it replaced people paddling boats, and it replaced wind as the main source for shipping. Computational automation is having a similarly large effect in this century. Its origins are often traced back to the early 19th century and the introduction of the Jacquard Loom, an automatic weaving machine invented by Joseph Jacquard. One of the innovations of the Jacquard Loom was a series of paper cards with holes punched in them that passed through the machine to change the pattern of the weaving. The cards contained an algorithm for particular weaving patterns. Similar punched cards were used for automatic player pianos, and punch cards were also used to program early computers in the 1940s and 50s. The Jacquard Loom was extremely controversial at the time because many workers in the weaving factories felt, probably rightly, that their jobs were being usurped by this machine. There were many industrial relations issues that came about because of this technological change. One of the main protagonists against the Jacquard Loom was Ned Ludd, after whom the protest movement known as the Luddites were named. Those opposing technological advancements are, even today, often called Luddites. Another big issue around the automated loom was children's working rights. Kids were often employed in factories at this time, and the design of weaving machines reflected this through the lowered heights of controls. This is a clear example of how the design of technologies often reflects social conventions and practices. This practice of child labour changed as organised schooling expanded and people protested that children should actually be going to school rather than working in factories. Computing systems began to emerge in the mid-1900s and have dramatically changed what we know and what we do. What's interestingly different about automation with the computer is that instead of replacing muscle, like the Jacquard Loom replaced human labour and the coal-fired steam engines replaced horse labour, the computer has replaced intellectual work. In particular, the tasks of mathematical calculation and electronic communications. There's a very interesting connection between the telecommunications hardware, like telegraphs and early telephones, and the early computing devices. Images of early computers show how cables were used, patched things together and connected elements. These early computers had an uncanny resemblance to the telephone exchanges of the same era. The history of computing has often been dominated with stories of men like Alan Turing and Claude Shannon. but in recent times the important role of women in this history has become more prominent. For example, the film Hidden Figures tells the story of some African American women in the US who were working for NASA. They were working as what at the time were called human computers to do math equations. They subsequently became the first programmers and operators of electronic computers. Similarly, the television series Bletchley Circle featured women working at Bletchley Park, a location for UK military intelligence in the Second World War, where Alan Turing was also working. One of the significant achievements of the people at Bletchley Park was to break the code of the German Enigma machine so the UK military could read the transmissions of the German army, and that assisted them in winning the war. In recent years, automation has had a significant impact in the manufacturing sector, with advances in robotics. These are used for many tasks such as assembling automobiles and gathering orders for online shopping services. There has also been a revolution in knowledge work, with advancements such as online search engines and automated travel directions. As we can see from these examples, technological automation of physical and intellectual tasks has the power to transform society. And as with burning fossil fuels to power these machines, they can also affect the global climate. The task then, when designing interactive systems, is to harness the power of automation whilst being mindful of any potentially negative consequences.